To this video, and in this video we're going to discuss the quadratic function. Okay, the quadratic function is written in the form of f of x is equal to ax squared plus bx plus c, where a cannot be equal to 0, because if a could be equal to 0, it will lead you back to your linear equation. Now, the degree is 2 and the graph is a parabola. If you have a Cartesian plane, this is how it looks of a parabola. It could be like that, or this method, or that way. Now, we have one form of a quadratic function which is known as the vertex form. So, the vertex form is the leading coefficient, which is a, and then multiply to the square root of x minus h and k, where we say that h and k is the vertex in the graph, as you can see, assuming the graph here is the turning point of the vertex. As you can see, that is now the vertex. Okay. Now, at this point in this video, what we're going to do is to transform a quadratic function to the vertex form. Now, let's have it. Let's have here an example. So, this is now a quadratic function, which is f of x equal to x squared minus 4x minus 5. Now, what you're going to do first is to rewrite your function, grouping all the terms with variable. So, assuming you have now f of x is equal to, so we group now x squared and minus 4x minus 5. As you can see, this is now the first step or the setup that you work. Now, think of perfect square trinomial. So, on the variable, you can now look now on the perfect square trinomial. So, this is now if the case, if a is equal to 1. So, working with that, let's make this a perfect square trinomial. So, if a is equal to 1, you'll just divide this by 2, the negative 4, and then square it. So, that would be 4. So, f of x be equal to x squared minus 4x plus 4 minus 5. When you add 4 here, you need to subtract 4 here to make the equation correct. So, that would be plus 4 minus 4. In that sense, you see now, you just add 0. Now, going that, so since that is a perfect square trinomial, what we have there is f of x be equal to, working on the square of binomial, so x minus 2 squared minus 9. So this is now the vertex form of the function x squared minus 4x minus 5, where the vertex would be equal to 2 and then negative 9. Let's have another example. Now, this example, if a is not equal to 1. So, therefore, our a is equal to 3. So, there will be an additional step on how to look at this one. First, once again, you set up now your function where you group now with the variable. So, I'm setting it up 3x squared minus 12x plus 1. Makes sense. Now, this would be the additional step. You factor out the a value or the leading coefficient. Our a value here is 3. So, you factor out 3. So, we have now 3. Then, this would be 3x squared divided by 3. That would be x squared. Negative 12x divided by 3. That would be negative 4x plus 1. Now, since now, what's inside now a grouping is a quadratic where a is equal to 1, we can do now the perfect square trinomial as a concept. Now, you add now 0 in a value in the form of f of x be equal to 3 times x squared minus 4x plus 4 plus 1. However, what you need to have is a 0. So, there is a commutativity. So, 3 times 4, so that would be 12. However, you need to put that here, minus 3 times 4. Since you have 12 here, you have 12 here when you have a product of this one. So you need to deduct that. So what's left there, or when we simplify now the expression, we have now f of x be equal to, and then this would be x squared minus 4x plus 4 plus 1 minus 12. Now, we are having now the setup, so getting now the square binomial of this one. So we have now f of x be equal to 3 times x minus 2, but that would be unsquared, and then minus 11. Now, getting now the vertex, getting the additive inverse of negative 2, that would be 2, and then negative 11 as your vertex. And that's it for the vertex form of the quadratic function 3x squared minus 12x plus 1. So I hope you learned something with these two examples. You can explore with that, and in the next video, we're going to have another exploration about the graph and evaluation of the quadratic function.